Hi, this is our presentation for our project Automated Pesticide Sprayer using image processing tools for use in mixed orchards under the aegis of Texas Instruments India Analog Contest 2014. Pesticides are one of the main factors of contamination of groundwater due to their high solubility and hence very difficulty of removal due to purification processes. Hence, we try to optimize the usage of pesticides on trees to avoid their excessive usage. We basically, this is the hardware of our system. We take an image of the tree via wireless camera that we can model it using the mobile, and we take up the lower half of the tree, which has most part of the canopy and the trunk. Using this image, we estimate how much pesticide is to be sprayed on the tree.
This is the software part of a project. A software part consists of two blocks. The first one is image processing, while the second one is machine learning. This is the block diagram of a image processing part, where the input to the start is the input data image, which is the image of tree. The input image is then passed through a filter. The filter is basically a Gaussian filter, which is used to reduce the noise. After using the watershed algorithm, we are able to segment the leaf into individual segmented leaves, which is then used for input image for our machine learning algorithm. The machine learning algorithm is basically a KNN approach, which is used for clustering. As you can see, the MATLAB code for image processing. This is the input image. After using the watershed algorithm, we are able to segment it into individual leaves. These are the individual leaves, which will then be used as an input to our machine learning algorithm. This is our input image, and while these are our final outputs. We have created a database out of images from the internet. This is the database created for apple, while these are for mango as well as orange. These images depict real world scenario. After segmenting all the images, we are able to form a database. These are the segmented part of leaves. The output of an image processing part will then be used as the input for machine learning part. This is the code written in OpenCV for machine learning. The algorithm for machine learning which is used there is the KNN approach. It basically clusters our entire dataset into three kind of clusters. These clusters depict three different kind of trees. For our input of this mango tree, and using the segmented leaves as input, the cluster found is number 1, which is detected as mango tree. The clusters are labeled based on database images. We have used an apple tree as the input image, and see, as we are able to get the class detected is number 3 and the tree detected is apple.
This is the microcontroller interface of our system. This is a relay, three-way relay system which helps in selection of the pumps and their subsequent operation. This is the driving system for the relays. It helps in driving the pumps and selection of the relays. This is the microcontroller which is used for driving the motors for vertical transmission of the nozzle system. This is the decoder 74139 which helps in connection of the microcontroller system to the motor driving circuit. Here we are using 3 TIIC components: MSP430 launchpad, MSP430 launchpad and one 74139 decoder. So this forms our microcontroller system. This is our hardware. The hardware consists of a rectangular board 21.5 cm in length and 15.5 cm breadth. Two motors are used for vertical transmission of the nozzle system. Both motors are high torque 10 RPM motors with the rubber wheels 1.5 inches in width. A pipe is attached to the nozzle system. 3 pipes are attached to the nozzle system, and they are used for pumping the requisite amount of pesticide. Now we will show you a live demo of the system. The trunk width has been detected and the canopy has also been identified. The pesticide is being sprayed at the only requisite height for the tree. As you can see, the whole canopy is being covered by the height. As you can see, the movement of the pesticide sprayer is exactly confined to the canopy of the tree. And the height hence is a function of the image we have taken. Now we will test the system on the apple tree. The apple tree, as you can see, is of a shorter height and hence a proportional smaller width. We will take the image of the lower side of the apple, including the leaves and the trunk. Now the pesticide will detect according to the leaves and according to trunk width, will spray the optimum amount of pesticide at optimum height to the apple tree. Now we will test the system on the apple tree. As you can see, the apple tree is quite small as compared to the mango. Its trunk width is proportionately smaller. We take the image of the apple tree's lower part having the trunk width and the lower part leaves. Based on the lower part leaves, it will identify the tree as the apple tree and spray the pesticide. And based on the trunk width, it will spray the pesticide for corresponding time, and it will switch on the motor for the corresponding time. As you can very well see, the water doesn't go beyond this point and doesn't go even very concentratedly below this point. So it covers the whole canopy. We will now repeat the same procedure for orange. We will take the image of this lower half and using the leaves of the lower part and the trunk width, we will estimate how much pesticide and which pesticide to spray. Hence our pesticide sprayer sprays the optimum amount, not too excessive and not too less, preventing the infestation of harmful pests. I would like to thank Professor Amit Sethi for his guidance to our group and to all our family, classmates and friends for their unwavering support throughout the course of our work. Thank you.